I want to give you an overview of lab number 6, the coefficient of friction lab. The idea of this lab is that we want to try to determine what the coefficient of friction is between two surfaces. And you know from the notes that depending on exactly what's happening, we'll either have static or kinetic coefficients. Now I can tell you in this lab, sort of the whole setup of it is that we're taking an object and dragging it across a desk. And so throughout the entire lab, there are things sliding across each other. So if that gives you an idea about whether or not we're going for static or kinetic friction, yeah, who knows. But the idea is, in the actual lab that we would usually do for this, is we have these wooden blocks. They're a little bit bigger in size this way than a cell phone, and maybe about an inch thick or so. And there's a little hook on the end that we can hook a spring scale onto. And when you pull on the spring scale, it gives you readings of forces in newtons. So the idea is that if you have that block sitting on the tabletop and a spring scale, and you start pulling it, you can pull it along and measure the force from the spring scale, your applied force. Okay? Now, the way that we're looking at this is, and again, it's where things are not exactly perfect, is that as you're pulling it across the table, what you're supposed to do is try to get it to move at a constant velocity. Now, think for a second. If we are saying that the block is moving at a constant velocity, no acceleration, which of Newton's three laws are we really saying we're using? Okay, so I want you to think about that. Because what we're then able to do is we're able to measure the force that you're applying. And in some way, if you're using the right one of Newton's three laws, you can then say something must be true about the force of friction that's opposing it moving. So you've got several trials that you're supposed to do, where you first have the wooden block, and we know the mass of the wooden block, and you pull it, and you've got it moving at a constant velocity. And then the same wooden block, you stack something else on top of it. So you have additional mass now. You have a total mass, right? And you pull it again. Now, since there's more mass, not really a big surprise here. I'll give this away. You have to pull harder just to keep it moving at a constant velocity. Again, okay? And then we put another mass on top and we pull it. And basically over several trials, we use increasing masses, this total mass of thing that you're pulling, while seeing how much applied force it takes to keep it moving at a constant horizontal velocity. Now, what we're able to do, and this is why drawing a free body diagram in the pre-lab is quite important, is we can relate everything that we're doing then to the formula FF equals mu Fn. Because there is a way from everything that we're doing to get FF. There is a way from everything we're doing to get Fn. Those are numbers that we can calculate or are basically right there in front of us from the numbers that we've been collecting in the lab. And then we can find a value for mu. Now, little extra special bit here. We are going to do a linearization for this. And it's actually not even something we have to really linearize. Hint, hint. It's just stuff that you're going to graph. But if you think about the formula for friction solved for mu, you should have an idea of what goes on the y-axis and what goes on the x-axis, because we're going to use the slope from that graph to get our value for mu. Now, one thing I would suggest is when you take the numbers that have been supplied to you for doing all of this, is, go through the whole process, do the graph and everything, get your slope, and then there is something that's a very definite tell if you've been doing things correctly. Because if you did things correctly, the only possible numbers that can happen for a coefficient of friction are numbers between 0 and 1. So if you find that you've got a number that is wildly different than that, then something is wrong. If you've got like a negative value or you have a value that's bigger than 1, you've got to look back and double check some stuff. So what you need to do is look at the data that's been supplied to you for this and start looking at how you would build this all up into a doable lab. And remember, you are doing a full lab write-up for this. So it has to be a complete full lab write-up using the template that's been supplied to you. If you have any questions, try to get in touch with me and I'll try to answer them as best as I can. Thanks.